Welcome to The Explainer. So, today we're diving into a topic that's absolutely crucial if you're working in modern cloud native environments. You know, when senior cloud architects get together and talk about what literally keeps them up at night, it's actually not always massive cyber attacks or catastrophic hardware failures. Honestly, it's often something way quieter. It's a really insidious phenomenon called configuration drift. And trust me, it is the silent threat to cloud reliability. Okay, so here's our roadmap for this explainer. We're going to start by unpacking this silent cloud threat, then we'll break down the anatomy of configuration drift. After that, we'll look at the compounding operational risks, figure out how to restore order using GitOps, and finally wrap up with some rock-solid best practices for consistency. Let's jump right into Section 1, the silent cloud threat and our vulnerable landscapes. Look, we all know modern cloud environments don't just sit there gathering dust, right? They're constantly evolving. Every single day, you've got infrastructure changes, you're continuously deploying applications, and you're probably scaling across multiple global regions. Trying to keep all of that perfectly aligned, well, it's a monumental operational challenge. So, what exactly is configuration drift? Basically, it happens when the actual state of your infrastructure, meaning what is physically running right this second in your cluster, differs from your intended or documented state. It's that scary gap between what you thought you built and what's actually operating in reality. Moving right along to Section 2, the anatomy of configuration drift, or exactly how this gap forms. Here's the thing. This gap rarely happens overnight because of one massive event. It sneaks up on you. It usually starts with something super well-intentioned, right? Like a manual change, or maybe one of those panicked 2 a.m. emergency fixes to just get a database back online. But then you add in inconsistent deployments, maybe a lack of strict automation, and some poor governance, and suddenly, your environments are a total mess. The infrastructure literally starts shifting right beneath your applications. It's a really stealthy problem, but it actually follows a pretty predictable life cycle. It starts out completely secure and perfectly governed, but then it just inevitably marches toward instability and eventually a full-blown crisis. Let's look at how this snowball effect actually happens. Step 1 is your safe Git state. That's your documented source of truth. Everything is good. But then Step 2 hits. Somebody makes a manual, untracked, or maybe even unauthorized change directly to the live system. Bam! That triggers Step 3, configuration drift, where your actual environment splits from your blueprint. Naturally, that divergence leads to Step 4, which introduces severe security risks and policy violations. And then the grand finale, Step 5, a production incident. We're talking outages, data loss, and some really angry customers. Which brings us to Section 3, the compounding operational risks and the fallout of this whole lifecycle. Drift creates this terrifying cloud of uncertainty. Out of nowhere, senior engineers find themselves completely unable to confidently answer the most basic questions about their own systems. Think about it for a second. If the documentation is wrong, how do you actually know what's running? How do you know which configuration is correct? How can you tell which changes were actually approved, or if your environments are even compliant anymore? You're basically flying blind. And the consequences of flying blind are pretty brutal. You're looking at major reliability problems because your apps are going to behave totally unpredictably across different environments. You're opening up massive security vulnerabilities because standard controls are just getting bypassed by these manual tweaks. Compliance violations go through the roof. And honestly, perhaps the most painful part for cloud engineering teams, incident resolution takes infinitely longer. Troubleshooting just becomes this nightmare guessing game, all because your documented configs don't reflect reality. So the undeniable warning here is pretty stark. The bigger the drift, the higher the risk. Every single untracked change just compounds the danger to your entire cloud architecture. All right, Section 4, restoring order with GitOps and getting back to consistency. The good news? There is a proven architectural solution for this. GitOps is a framework designed specifically to eliminate all of this uncertainty. The golden rule of GitOps is that Git must become your absolute, unquestionable source of truth for all infrastructure, no exceptions. By relying entirely on Git, successful cloud teams can actively detect, prevent, and fix drift. The core mechanic behind all of this is a continuous, rigorous, and automated comparison between two things. On one side, you have your desired state, which lives safely in Git. On the other side, you have your actual state, which is what's running in your cluster right now. It's a constant tug of war. Because you've defined that desired state so clearly, You can use tools like Argo CD to continuously monitor everything. When differences inevitably pop up, say when someone tries to make that rogue 2 a.m. manual fix we talked about earlier, these tools step right in. They use a process called reconciliation to instantly and automatically overwrite the drift. They literally force the system back into perfect alignment with your Git repository. The system just does not allow the drift to exist. Finally, Section 5, Best Practices for Consistency. Let's look at how we can eliminate drift for good. Translating all this theory into concrete, actionable steps starts with one absolute rule. You have to entirely eliminate manual production changes. Just lock it down. From there, heavily automate your deployments and strictly use Git as your single source of truth. On top of that, implementing policy as code is a huge game changer because it ensures no configuration can even be merged into Git without passing your security checks first. And lastly, continuously monitor your configuration state so you're literally never caught off guard. The operational payoff for doing all of this is just massive. By preventing unexpected outages, you keep your environments totally predictable. You vastly improve your compliance by actually staying aligned with regulations. You boost overall reliability, massively cut down your troubleshooting time by removing all that guesswork, and you maintain absolute consistency across every single environment. Look, it all comes down to this core mindset. Consistency is not a convenience. It is a requirement for operational excellence. I love that quote. If you treat consistency as just a nice to have, your systems are absolutely going to fail eventually. So take a hard look at your own deployments today. Is your cloud infrastructure actually running strictly on intended configurations, or is it silently drifting right now towards your next major production incident? Definitely something to think about. Thank you so much for joining me for this explainer. Now go lock down those environments.